The third ring is using auditory notifications. The fourth ring is using thermal notifications, and the last ring is using light notifications. Now, the first question that comes to mind when you see this is like, if you want to understand different channels of notifications, why would you develop interactive rings, which is not a very common device at this stage? So the reason why we decided to go for rings here is that for all of our different channels of notifications, the ring is a perfect device. The location of the finger is very sensitive to the different haptic forms of feedback. So for the vibration, the poke, and the thermal notifications, it's very easy to perceive. And at the same time, your finger is not often occluded by clothing or other things. So therefore, also for light and for auditory feedback, it's a very appropriate type of device. At the same time, we were interested in general whether interactive rings could be an interesting form of notification device for future applications. So let's talk a little bit about how we developed this. In general, all the rings are powered by a central processing unit we developed, which communicates with a computer and which sends notifications to the ring and therefore transmits them to the user. And the rings themselves consist of two shells of PLA that are connected together and hollow in the inside. And in the inside, we integrated the different type of actuators that actually convey the notification to the user. For each of the different rings, we use a different actuator, and I will shortly show them so you have an idea of what the different types of actuation are like. The first one that we use is a poke, where we used a solenoid, a linear solenoid that is essentially pushing on your skin. For the second ring, we used a simple vibration motor that is using vibration and it's integrated in the ring in a slightly bigger shape. For the third one, we used two bright green LEDs. The reason we choose green here is that in previous research we found that green is the easiest perceivable color for notifications. So that's why we used green here as the color for notification. For auditory feedback, we integrated a piezo buzzer, and we made a little hole in the ring so the sound could actually propagate to the user out of the shape. And the last one is the thermal notification, where we used a series of resistors that slowly heat up over time. I will get back to that because that kind of presents a little limitation that will be clear from the results of our study. So the study itself, we wanted to understand how the different channels of notification are used in especially mobile contexts. And the reason we choose for mobile context for this is that in general, when we are on the move, this is the moment where notifications are the most relevant or the most interesting to perceive. And we wanted to cover the whole range of different kinds of mobile contexts. So we did it in a gym where we could control the actual level of mobility of the user, and we used 5 different types of activity. So the most passive condition is the laying down condition, where the participant lies down on the floor and receives the notifications with the ring. Then we have sitting, standing, and then 2 active conditions, which is one walking and one where we are running. Now, for the last 2 conditions, we used a treadmill device in the gym, as you can see in the background picture, where we could control the speed. So all the participants were running and walking at the same speed in order for fair comparison. The procedure of the experiment is that the users received a notification with all of the different rings. And as soon as they received the notification, they were asked to respond to that by pushing a big button on the central processing unit. And in doing so, we recorded the time in between the actuation and the response of the user. And we refer to that as the response time later. And also, if the user did not respond in time, and not responding is recorded after 20 seconds of notification. If the user did not get back to it, then we call that an error, and that will later on be referred to as error rates in the study results. So let's have a look at those results. One immediate thing when you look at the response times is that the thermal notifications were incredibly slow. Now, that is probably true, but at the same time we need to make a little note here that the thermal notification also took more time to actually reach the user. So we started the notification at the time slot which we recorded, but then it takes a little bit of time for the actual ring to heat up And that time is, we calculated, is about 6 to 7 seconds. But even if you would reduce that amount of time from the graphs, you would still see that the thermal notifications are considerably slower than the other types of notifications. Now, if you zoom a little bit into the other results, it also becomes clear that poke, vibration, and sound are incredibly fast in their response time. So you get a very quick sense of it, and also it's stable across all the different levels of activity. So regardless of the level of activity, you will still quickly be noticed with those three types of notification channels. What then also becomes clear is that light, which is in between, is actually a little bit slower than the other media. When we're looking at the error rates, we find that two interesting trends appear. I left out the other notification channels here because they have like almost no error rate. They all have been noticed. But if you look at the heat notifications and the light notifications, we see that the thermal notifications get less errors, though they are easier to notice as the level of activity increases. And with light, we see exactly the opposite trend. So as the light notifications get harder to notice as you get more active. And the reason we think this happens is something we found in biology, that when you are like active, when your body is active, you're trying to get rid of your heat. And when you're then like inputting heat as an external input to your body, that is something that feels uncomfortable to your body, so you notice it easier. And with light, it's probably related to the focus of attention. So when you're running, you're active and you're like looking forwards in order to stabilize your body, whereas light requires you to actually put your attention also on your hand to actually notice the light. So these are probably the explanatory factors for these trends. So on a higher level, what did we learn here? One thing we found is that vibration appears to be the most suitable for design of interactive rings. And this is a combined conclusion based on the response times that you just saw, but also on the preference score. So it scored relatively high on preference, and it scored significantly higher than sound, which is interesting because sound is typically something we use now in mobile applications. So this could be an interesting extension for a specific focus on interactive rings. We found that the noticeability of heat improves with physical activity and light gets worse with physical activity. So this might indicate something that if you are designing active applications or applications for an active scenario, it might be actually interesting to take these into consideration. The last conclusion that we found is that poke is received relatively well as a notification channel here. It got high preference scores, and it also performs really well on all of the other stats that we found. So with that, I would like to conclude my presentation, and thank you for your attention, and I'm open for any questions.
Antonio Krüger, DFKI Saarbrücken, Germany. Thanks, very interesting, inspiring. I was wondering if you've thought a little bit about generalizing your findings, because you had this special situation of running on a treadmill. And the first thing that came to my mind was the notion of change blindness, which is well